video, we are going to talk about linked list, particularly singly linked list. Before getting into programming part, let us have a brief introduction about arrays and linked list. First of all, to store a data, we need to declare some variable like int, float, char, etc. An array is a collection of elements having same data type. This statement int marks 10 will tell the compiler to allocate a continuous block of memory holding 10 elements. Each block can hold an integer value. The memory arrangement of these blocks are continuously allocated. The whole 10 elements can be referred by a single name, that is marks, with index starting from 0 till 9. But the elements are not stored at continuous memory locations in linked list. In simple words, a linked list is formed from many nodes linked through a pointer. A node is nothing but a packing of data and pointed to the next node. Here there is an external pointer called head. The head will point to the first node, and each node consists of the data and the pointer to the next node, and the last node will point to null, which indicates the end of the list. This simple list is called singly linked list. Now we may have a question like, why linked list instead of arrays? Linked list provides flexibility in allowing elements to be rearranged so efficiently, like inserting an element, deleting an element. To insert an element in array, we have to move every element a step towards right. To delete an element, we have to move every element towards left. So it's a time consuming process, right? And the memory allocated by the array is static, so we can't free up memory space. In this illustration, we have three nodes A, B, and C. A is pointing towards B, B is pointing towards C, and C is pointing towards null, which indicates the end of the list. To insert an element, we just need to change these pointer values, like A's pointer is pointing towards X and X pointer value is pointing towards B. Now an element is inserted at in this position. So now it may be a little confusing. After getting into the programming part, we can understand what this all mean. Also, to delete an element, we just need to change this pointer pointing towards this and free up this memory space. In C programming, we use structure to implement linked list. We can ask like, why we use structure to implement. With structure, we can pack data of different types. First, let us have a template for the nodes with integer data and a pointer, structure pointer of type structure nodes with the name next. This is a template for the node. Then we type def this struct nodes with the name node. So I have did this just to make typing simpler and make the program so easy to read. Now let's declare some nodes n1, n2 and n3 and a head pointer to point towards the first node. Let's give some values to the nodes. n1.data equal to 5, n2 data equal to 6 and n3 data equal to 7. Now we have given the value to the nodes. Let's have a linkage. First we have to give the head pointing towards the n1 and the n1's next pointer pointing towards the n2 node. So we have to give address of the next one, and n2 dot next equal to the address of third node, and here it's the last node, so we have to give a null value which indicates the end of the list. Now we have declared three nodes n1, n2 and n3 with their data, and they have the linkages. Let's try to print the list. Let's declare a function with the name print list, the parameter head. Let's have a temporary node pointing towards the head, Then we follow the temporary variable until it becomes null, which indicates the end of the list. Then we have our print statement. As its integer value, we use %d with the space for easy reading. Now we have to print the data. Then this temporary variable will always point to the particular node. We have to move it to the next nodes, right? So temp equal to temp the next node. Let's have a new line here just for formatting purpose. Let's try printing it. Print list with our parameter head. Let us run the code. Yeah, now we got the 3 value, right? 5, 6 and 7. Let's try to insert a new node here, n4. Let's declare a node n4, give its data in a value like 8, and this n4 pointing towards the n3, so it is inserted before n3, address of n3, right? Then n2 is pointing towards n4. Let's try printing it. That's it. We inserted a new node in the middle. That's before the third node. 5, 6, 8 and 7. Let's try removing the head. You can easily remove the head by making the head pointer pointing towards the next node. Let's try printing this. See, now this node 5 is removed. We have our 3 values 6, 8 and 7. Now we have our 3 nodes n1, n2 and n3 statically allocated and used, but it is not the way we use linked list. Linked list is used when the number of elements is unknown. Now let's create a function to create a node with a name create node. We are passing an integer value to it. Then we declare our result node and allocate memory using malloc with the size of node. Let's give this result node a value which is passed through function. Then we give the pointer pointing towards null. Then we return it. Here let's remove this all statically allocated nodes. Remove all this. Now let's have a dynamic allocation. For this we have a temporary node. Let's create a node. Create using the function create node by passing a value 5. Then we make this head pointing towards this value. Again we create another node, the create node function with the value 6. Then we make this pointer pointing towards the head. With this we can put the variable in front of it, like before 5 we put the value 6. Now we have our head pointing towards this temp. Again we create one more node using create node with value 7. Then we have our pointer pointing towards this head towards this temporary one. Now it may be a little confusing. Let's print it. It will clear all this. Let's clear this terminal. Let's run this. So here we have include the standard library for using this malloc. Let's include this. Include stdlib.h. Let's run this. 7, 6 and 5. See, we have printed the values 5, 7, 6 and 5. We can ask like why the elements came before. We have read that first we have created a node with the value 5 and the head is pointing towards that node. Again we have created a new node with the value 6 and that node's next point is pointing towards the head. So then the head is pointing towards the term. Now the node created with the value 6 is our head and the next node is the head before, that is 5. The same is happened here. Created a node with the value 7 and the next pointing towards the head and head pointing towards the newly created node. You can see here that we are repeating the same set of statements again and again, like creating a node and assigning it to the temp variable and pointing the next node towards the head and head towards the temporary variable. So let's simplify it using a looping statement. For let's have a integer I just for this loop. I is equal to 0, moving it until 25, 24. Let's have the statement inside the loop. With the values of y. So now we are creating a node and assigning it to the temp, and the next node is pointing towards the head. So now the head should be null at the beginning. Let's try running this code. Here we have our list. Here the elements added one before the another. Create a function to simplify the statement, that is adding a node at the head. First we declare a function with the name insert node at head. The parameter head and node to be inserted. Node to be inserted. Let's have the definition here. It returns a node pointer. Let's assign this node to be inserted. Next, point towards the head and return this node to be inserted. Here we can remove the statement. That's what we are doing here, like the node to be inserted, the new node pointing towards the head. Let's assign this head node to be insert node at the head with the values, the parameters, head and new node. It's temp one, right? So we can remove the statement also by creating the node and pausing it at the same place. Let's try running this code. Yeah, it still works fine, right? Here we don't want to assign our head's value. We can do this by a little change by setting the address of the head and changing this to double pointer I'm changing the value of the head here, like here star head, because we have made it as double pointer. Asterisk head equal to not to be inserted. So which is the next now? Not to be inserted, right? So we don't want to return any value here. We can remove this return statement and make it more simpler. We can make the statement y. Let's run this code. See, again it works fine, right? Let's create some more functions. First, to find a node, let's create a function find node. We need to pass find node. We need to pass the address of head. Then we need to pass the value to be found. First, let's have our temporary variable. Temporary variable pointing towards head. Then we traverse the whole list until it becomes null, which is the end of the list. Then we are trying to move towards the next value, right? Next node with the statement. Then we need to find the value temp data if equal to the value which passed to the function. We need to return that address, right? If the value is not found at the end, let's return null. Let's try running. We call the find node function with the value maybe 10. Then let's print that with this printf statement. Find let's have this function in a variable temp, and let's print the value. Let's make it more readable, like found value is. Let's try running it. Here there's an error. Too few arguments. Yeah, you need to pass the head, right? Address of the head. Now let's run it. Yeah, we got it. Found value is 10. That is the value 10. Let's have some more functions like to insert a node after a node, like with the name insert after node. We just need to pass the node to be inserted, node to insert, then the new node's address, new node. To insert a node, the new node's next pointer must point towards the node to be inserted after the next value. Then we have this node to be inserted, next value point towards this new node. And just to make sure it works, let's insert a node, insert node after the node which we found the value 10 with a new value 75. Here we have created a node with the value 75 and inserted the node after this value 10. Let's comment this out. No, let's leave it. That's fine, right? Let's have a new line here just for formatting purpose. Let's try running it. We have our print list function here. Let's try running it. Now we can see that the value 75 is inserted after this value 10. We need to be aware of the looping in a linked list. Like in the statement, in this function insert after node, if you do like this, like replacing the statement before the statement will give us a infinite loop. Let's run this code. See here, we got this infinite loop. Let's terminate it. So we have a imagination over how the elements are linked together for easy going of linked list. Let's change this as before. Let's run this code now. See, we have our normal list. That's it for this video. Thank you for watching. Have a nice day.